guys, my name is Santosh Lohar and welcome to my YouTube channels. And in the previous video we discussed about the machine learning and its type, and we have discussed many things like what is machine learning and what is AI and how it works and what is the dependence and dependence variables and supervised and unsupervised learnings. And in this today's video we will try to discuss about the linear regressions, which is an important part of machine learning algorithms. So let's start. Linear regression analysis is used to predict the value of the variable based on the value of another variables. The variables we want to predict is called the dependent variables. The variable we are using to predict the another variable is called the independent variables. As you know that we have already discussed about the dependent and independent variables. Dependent variables means the output variables. It will be the one output, and independence variables it will be many variables, just like height and other things will be. And the linear regression is a fundamental machine learning techniques for modeling the relationship between the dependent variable, also called target or output variable, and one of the more independent variables, also called the features or predictors. It is commonly employed for the tasks in predicted models and data analysis. It means we will examine or predict the dependent variables as per the independent variables. Dependent variable means it is the outputs and it will comes according to the independence variable. In simple learning regressions, there is only one independent variables, and the goal is to find a linear equation that best represents the relationship between the independent variables and the dependent variables equations. Equations of some linear regression is, as you know, we have already discussed about and we have already studied about the equation of the straight lines. Y equal to mx plus c. It means we have described it. What is this? So y may be defined as the dependent variable. Dependent variable means it is the outputs. It will comes and we will get on the basis of the independent variables. Y equal to mx plus c. It means it is the straight lines. And in the machine learning algorithms, we have to find the best fit lines. That is noted at y equal to mx plus c, and it is the simple linear regression equations where y equal to mx plus c, where y equal to dependent variables, and mx plus c, where m equal to slope of the line, how is the slope is going, and x equal to independent variables, it will be many, and c means y-intercept, means the line, the straight lines passes through the origin is known as the y-intercept. Note, I have also mentioned the note. C equal to is the y-intercept, the point where the line intersect the y-axis. It means y-intercept means the point where the line intersect the y-axis. So in the following figures, we as per the following examples are taking in instances. The objective of linear regression is to be determine the value of m and c, that minimize the difference between the predicted value mx plus c and the actual value of the independent variables y in the data sets. This is typically done using by a method called least squares, which finds the value of n and c that minimize the sum of squared difference between the predicted and actual values. So, as per the taking example of the figures now here, this is we have already discussed or we aware of these figures and taken y-axis and its value will be height, and take an example of weight as a x-axis, and take an example take some points, that this point and this point and others, and these points will be, this is called the this is called the actual value, where we have determined the any points, and this dotted is called the actual value, predicted values, where we are going to predict the difference between the actual value and the predicted value is called the residual errors. This is the distance, how much distance will be it covers the actual value and the predicted value, predicted actual, and that this line is to be known as the best fit line. And we also mention the hypothesis here. So model makes this line best fit line hypothesis. So we need to discuss what is a residual errors. A residual error means, guys, this is the theoretical portions. We must have to describe the theoretical basis. We have to go in theoretical basis first of all, because we need to know what are its foundations. We have to make our foundation strongly to describe our upcoming classes and all related algorithm related to machine learnings. So we need to understand its foundations, its basics, how it works, and what its small points to be discovered here. So residual error means distance between actual value point and the predicted value. We have defined some predicted some points, and if we predict some points here, and the actual value and the predicted value, and the difference between the actual value and the predicted value is known as residual errors. We must have to know about the residual error, what is residual errors is, and I have written some notes here. If we sum all the distances, the sum residual errors value must be very minimal to be a best fit line. It means to be a best fit lines, it means in this linear regressions we have to find the best fit lines. It means we have already given the some points and we have to predict, and the actual points we have determined, and the predicted point, and the difference between the predicted point and the actual value is known as residual errors. And from that we have to find the best fit line, and the best fit line and the sum, if we add the distance between the best fit line and the residual values sum, it must be the very minimal point best to be a best fit line. Minimal residual errors value will be accepted, and where minimal residual value is outed, then it will be accepted. To confirmed or to find out the minimum residual value, and that will be accepted. And even there is a many lines to be a best fit lines, it means to be a best fit lines, the value, the sum of the value between the residuals and the actual value will be the minimal, and it will be accepted. Minimal residual error will be accepted to be a best fit line. Now take an examples and linear regressions. Take two features x and y, and here we have given some weights which represents y, and taking a x-axis which represents age, and we draw straight lines, that is y equal to mx plus c. We already know as the straight line must be denoted as y equal to mx plus c, y equal to our output value, dependent variables, m is slope, x is dependent independent variables, plus c. This is the formula of the straight lines that we are going to be discussed over here. And from these figures, y is a linear function of x. This is the x-axis, this is the y-axis, and y is the linear function of x. This is the linear function of x. In linear regressions, we try to create a model with the help of the above training dataset. Dataset means we have given some datasets like we have discussed here weight and age, and according to these datasets we have to predict what will be the our predicted state lines, predicted value, and that predicted value will be the minimal sum of the residual value. You have to understand it. A model with the help of the above training dataset, first of all train a dataset and model, takes in input new as, we have to, that is taken as hypothesis, that is output, or output is predicted value, and is taken as per the above instances, it is the predicted value. So what is our output, that is predicted value. In linear regressions, we are trying to find out the best fit line which helps to predictions, which helps to do predictions over here. In linear regressions, it is basically means we are going to create a linear line over there. What will be the best fit line and how it will be calculated, how it will be discovered, how it will get it. When the summations between the predicted value and actual value will be minimum, the minimum residual value will be taken as a predicted value. Linear regressions, it basically means we are going to create a linear line over there. Equation of straight lines, we have already discussed about it. Y equal to mx I plus c, and it will be also notations. In a machine learning algorithm, guys, we have to take some notations to make the understand between all of the related to the machine learnings. So y equal to beta 0 plus beta 1 plus xi, where it will be written as s theta x upon I equal to theta 0 plus theta 1 x upon I. So it is the notations to be understand about the machine learning algorithms. the straight lines over here. We have discussed about the s theta of x equal to theta 0 plus theta 1 into x. In this figure, the straight lines which we have already discussed, the straight line is known as y equal to mx plus c, and the predicted, this is the hypothesis, it is the predicted value s theta of x is the y, it is also known as the straight line, equal to theta 0 plus theta 1 x. When x equal to 0 and theta 0 equal to intercept, means where the straight line passes through the origin, and theta 1 equal to slope are coefficients, and x upon x I equal to data points or actual points. Intercept, I have all the terminology I have discussed over here. At what points the straight line cut or touch the y-axis. Intercept means in which points the intercept cut the y-axis is known as intercept. Note, I have written some notes over here about the linear regression model. Unit moment in x, then what unit moments in y is called slope or coefficient. I have written some example here. In these figures, and the red predicted point, this is the actual point and these are the predicted points, and the actual point and predicted point is known as residual value error, and the summation of the residual value will be the minimums to be a best fit line in linear regression of the machine learning. If I do the summation of these points, those distance should be minimal, then only we will be able to say that this is the best fit line. The summation of the distance between the actual points and the predicted points is minimal, that is called the best fit lines to be a linear regression. If I take an examples of linear regressions, I need to find out the best fit lines in such a way that the distance between these data points I have a graph and the predicted points should be very less. We have already discussed it will be the minimal points to be a best fit line. And why you need to best fit lines? To find out the hypothesis, best fit lines, where we are going to be predict the data analysis of the data. I have written some notes here. In multiple lines, we use start at points and for best fit lines. We have to start at points to be a best fit lines. The distance between the best fit lines and the predicted points will be the residual value, and the summations of the residual value must be less to be a best fit line. And in this scenario, the hypothesis point will be come over here. Hypothesis. We have already discussed y is the linear function of x. Y means it is the output or predictions our hypothesis, and it takes some notations here. Is theta of x equal to theta 0 plus theta 1 into x1. This is a simple hypothesis which creates or make the best fit line once. over here. Try to understand, guys. This is the machine learning algorithm. We have to make some notes and we have to study some materials, articles related to it, and we have to make practices about this, and then we will be able to find out the best fit lines to be between the actual values and predicted values over here. Now here take an examples. Here this is the y-axis, this is the x-axis, and take this point. This is y-axis, and when theta 0 equal to 1.5 and theta 1 equal to 0 here in this figure, and this figure theta 0 equal to 0, theta 1 equal to 0.5, and with the multiple lines over here, then we have to calculate like this the best fit line. How we can find it over here? When the line passes through the worth intercept 0, always 0. We have already discussed about this. When the line passes through the origin or intercept theta 0, always will be the 0. When there are multiple lines to determine best fit line, in this case we should start from one point, and from that point line we need to adjust it to get a best fit line. And in this scenario the pictures will become of cost functions. What is cost functions? And before going to the cost functions, there are some notations will become over here. And the cost functions will be defined as it has some formulas which used in machine learning algorithms. Summations of m1 I equal to 1 by 2m has theta of x power by I minus y power by whole square. And what does it mean? This is the cost functions, and our main aim to minimize its value to get the best fit line. We have to minimize this best fit to get a best fit line, and we can also write these notations here. You have theta 0 comma theta 1 equal to 1 by 2m summation of m equal to 1 yes theta of x I minus y theta of 1 whole square. And this function is, this notation is called the squared error function, and where m equal to number of data points, how many data points we are going to determine over there, and the data points we will predict there, and there will be 2 points, then the one is actual points and other is predicted points, and between the actual points and the predicted points we will find the residual value, and to be a best fit lines there must be a minimum residual value, and to find the minimum residual value we use to cost functions by these notations. We have to find out sum of errors average, that's why we divide it. And about this explanation over here, yes theta of x equal to theta 0 plus theta 1 x bar I. This is the hypothesis that we are going to find, and we are going to predict. We are going to make the predictions where s theta of x I equal to predicted points. It is the predicted points. We have 2 points. The first one is actual and the one and there is predicted points. Y of x, y power I this is the actual points, and between the predicted points and the actual points there will be come out the residual errors, and the residual error must be minimal to be a best fit line. Now you can watch it in this figures. These are the predicted points of theta of x I, and this is the straight lines. Minimal this distance between the predicted point and the actual point, and we have to minimize the distance between the predicted point and the actual point to get the best fit line. Then we need to use cost functions. Why you need to use the cost functions? To make the best fit lines. And how we get the best fit lines? When the summations of the residual values, and how the residual value will comes, it will be the differences between the predicted point and the actual points. The predicted points and the actual points, when the values come out, if we sums that values, and when it comes at a minimal point, that is called the residual or predicted values, and it will be taken as the best fit lines. Then you need to cost functions to minimize the residual errors over here. We have to minimize the value of the cost functions through changing or altering the value of theta and theta 1. And how the value will becomes? Minimize the value of the cost functions through the changing or altering the value of theta and theta 1. We need to change the alter. Sometimes we need to change or alter the value of theta 0 and theta 1 in such a way that the value of cost function is minimal. When the value of the cost function is minimal, then the best fit will come over here. There, it means differentiation used to find out that point slope, and the hypothesis. We have already discussed about this functions and notation over here. As theta of x equal to theta of 0 plus theta 1 into x. In these figures, we have already discussed about the hypothesis in these classes. When theta 1 equal to 1, this is the training data. We have to put some data over here, and over the data, as for data, we have to find out, we have to predict some predictions value 1 1 2 2 3 3. These are called the training data 1 2 3, and over here is theta of x equal to 1 by 1 into 1. If we calculate these values, and s of theta x equal to 1 into 2, s of theta x 1 into 2, and these are the cost functions formula. And before it, let's consider theta equal to 0 to find out these values. Cost function formula: j of theta 0 comma theta 1 equal to 1 by 2m summation m I equal to 1 s of theta x I minus y of theta I of whole squares. If we plot this value in this functions, or this is in this graph, then j of theta over in y-axis, and if we put these values over here, and these are the global minimum. And this line is called the gradient descent or optimizer in data learning. And J of theta theta 1 equal to 1 by 2m summation I equal to 1 h of theta x I minus y whole square. And we plot the above values over here. And J of theta 1 equal to 0, we have already considered about it, and theta 1 equal to 1. Now plot in above 0 theta equal to 0 and theta equal to 1 over there. Now when theta equal to 0.5, then they of theta 1 equal to 1 by 2m summation m I equal to 1 h of theta x I minus y of whole square. Don't worry guys, we have to plot the points we have already discussed over here, and we find j of theta 1 equal to approximately 0.5, means this is the cost functions, and theta 1 equal to 0.5. You have to remember here these are the function or formula of notations of cost functions we have to find for here. Now gradient descent automatically change the value of theta 1, and unless and until we have to change the theta 1 value when not reach a minimal point. Until we have not reached the minimal point, we have to change the value of the theta 1 to reach the minimal point. In this scenario, the other algorithm will become in features convergence algorithm. It is optimized techniques. It means it optimizes the changes of theta 1 values until and unless we get the minimal points. Repeat until convergence means until we don't get the minimal points, we have to change the value of the theta 1 in actual points until we reach the global minimum. And here are some notations. Theta j equal to theta j minus alpha. These are the notations of the derivation of theta j theta j, and we have to mention or we have to know about these notations in cost functions. And this alpha is known as the learning rate. This equation is actually helps us to change our theta value much more efficiently to find the best fit line by calculating the cost functions, linear regressions, and these are called the derivative slope. So as per these calculations or findings, these are the j of theta. This is called cost functions over here, output functions theta 1, and we have to until and unless we have to change the value of theta 1 to find out the global minima to be a best fit line. So over here theta 1 minus alpha to be positive. If alpha equal to alpha has a huge value, then it will becomes nearly like this, and it will becomes in that point where the minimum value will become over here, and it will become the best fit line. It means reduce the theta 1 over here. It may be a theta 1 equal to theta 1 minus alpha. It will be positive, it will be negative. Note by what speed we should be coming to near global minima. Alpha learning rate usually a small value. In this video, we have discussed the cost functions, linear regressions, and how it will be notated and what its formula will be taken. We have taken some examples with the help of graphical representation over here, and equation the straight lines and how it will be notated in a machine learning algorithm in linear regressions. In the upcoming video, we'll discuss about the many things like we have already discussed in our first videos, like a region lasso, logistic regressions, how it will be calculated, and what will we get from it. It means we have to understand that what is actual value and predicted value and the residual value. Residual value means the difference, the summation of the difference between the actual value and the predicted value, and the we have to change until and unless we have to change the value of the theta when the global minima will be come over here. So thank you for watching this video, and in the upcoming videos we will discuss about other related machine learning algorithm. And please subscribe this channel, and I would like to request to please make it notes, and I will try to upload other materials or related to machine learnings in this YouTube channels. I have already made the machine learning playlist here.